Contact. I'm Erin Tournoux. I'm with PartsSource. I've been with PartsSource for about 6 years. We're based out of Cleveland, Ohio, actually Aurora, which is about 30 minutes south of Cleveland. I'm the current GM of Biomed. I was previously Vice President of Client Services. Within that role, we manage the Biomed group. So we have inside sales, customer service, and our implementation team. Within that group, our implementation team is really the ones that are rolling out our programs with our customers to include data delivery, reporting, analytics, all of the things that our customers need. So a lot of the data that we have a lot of it. We've been in business for 11 years, aggregating data from thousands of healthcare organizations across the country and service organizations. But what we've done is, one, we're looking to find answers within our own data to help us make good supply chain decisions, buying decisions, et cetera. But a lot of the data that we have comes from customer demand. So our customers have come to us and asked for better visibility on, one, how we're performing as a supplier, and then two, how a lot of the suppliers that we utilize perform. Benchmarking data has been a really hot topic for our customers as well. So they want to understand how they're purchasing compared to their peers, healthcare organizations that look and smell just like them. So we've been doing a lot with benchmarking as well. So we'll touch on that. But we've tried to make our reporting a lot more action-oriented and prescriptive, so giving the customer information that they can help make better decisions within their organization.
Okay, my name is Ben Larson. I work for Atlantic Health System. I'm an informatics specialist in the Biomed department. We're an IT department within Biomed. So I started off as a Biomed guy, an Army Biomed trained guy, and I've been doing it for 16 years. And I've merged really into databases. I got a bachelor's in database management, and I'm in a master's program at Villanova for analytics. So my passion within the program is really looking at the data we have and what we can do with it and what kind of value we can assess from it. The main thing I want people to see is there's a lot of data out there people aren't using. Your IT department's not capturing it all. It's kind of being thrown to the side, and that using some pretty inexpensive tools you probably already have on your computer, you can make something of this data, and you can provide value both clinically, operationally, and to a business sense. You can build forecasts and stuff. But it's using your data, using very cheap and easy tools to use. You don't need to become a PhD in data science to learn how to use this stuff, and I don't want people to be scared away from using it. The takeaways are, I want you to look at the data you have, not the data you want. There's a lot of information in there if you dig through it. It's okay. Nobody's data is clean. Nobody's data is perfect. Quit waiting for that to do something. Too many people are sitting on piles of data, not acting on it because it's not perfect. Got missing fields here. You can do a lot of work even with the dirty data, believe me. And reach out, try to become a resource to your clinical customers. Don't rely on just being the repair guy anymore. We want to be seen as a resource. Reach out to them, find what their pain points are. What is IT not providing them? You probably can get it. We own the data acquisition parts. We own the original data. There's a lot we can do that IT may not be providing them. And you can, by leveraging that, you can really become a resource and be seen at a higher level among the C-suites. Yeah, the first rule of data is analytics is you don't know what you don't know. Second rule is what you think you know probably isn't true. Once you start digging through your data, you're going to see that. You're going to see that somebody you thought was your top performer really isn't. We've got guys that everybody kind of talked down like they weren't doing anything. They were producing more than anybody once we started running the numbers. And you're going to see that equipment you thought was total garbage actually has a pretty good track record. Stuff you thought was great is costing you an arm and a leg. You know, one of the funny things about that is people become familiar with equipment they're always working on, so they think it's better. And they think the thing they don't see, the other thing when it breaks occasionally, they don't know it, so they don't like it, But the reason they don't know it is never break it. So maybe that's the one you should be looking at. And that's the kind of stuff you'll find when you dig through your data.
I'm sure you've all heard the phrase big data. Well, really, what is big data? Well, honestly, it's a buzzword. Big data really isn't one thing. Instead, it's a collection of technologies and concepts surrounding the challenges and benefits of working with big data, these massive data sets. Maybe you've heard of some of these, Hadoop, Teradata, MapReduce, NoSQL, data mining, machine learning. These all focus on working on these very large data sets. The easiest way for me to really understand is to break it down into two aspects. First, what I like to break down, as I refer to, is the data management aspect. This is your Hadoop, your Teradata. What these are is really just specialized databases designed to hold, collect, and manage massive amounts of data. The second aspect, this is your analytics side. This is the side that makes sense out of all the data. Let's face it, you can store all the data you want, but if you don't have a method of pulling any meaning out of it, what good is it? I mean, this is where analytics come in, really. This is what we're going to be focusing on today. Analytics is discovering and communicating meaningful patterns found in data. This is done through methods like data mining, statistical analysis. I want us to focus our talk really towards the biomed department, so that's what I'm going to be talking a lot today about. So, what are some of the challenges we have in dealing with this? Well, the first one we have is the optimal collection. In our hospitals, we have hundreds or thousands of devices in our hospitals right now churning out patient data continuously throughout the day. And we honestly don't do a very good job of collecting it. I mean, just look in the back of a ventilator manual. Look at the appendix for the parameters the vent's putting out through its little serial connector. It's like 200 parameters. And if you're connected to an EMR, maybe your IT department is collecting 5 or 10 of these parameters. They're just dumping the rest because they really don't know what to do with them. Half these parameters are providing real clinical information. The other half provide information on the machine itself, information we could use as a service department to better diagnose and maintain our equipment. But we really aren't using it. The second challenge is storage. Every sales guy out there is going to tell you storage is cheap. And compared to what it cost a few years ago, it's cheaper, but it's really not cheap. Good storage I would feel comfortable putting my data on. Well, that's going to run you about $1,000 a terabyte. So if you put up a 100 terabyte solution, that's going to run you $100K. I don't know about you guys, that's not really cheap in my book. Okay, the next thing you're going to need is data curation. Once you start to commit to collecting this massive pools of data, you're going to need someone to manage it. Active management is going to include ensuring data integrity, maintaining backups, tuning for performance. Make sure you're not corrupting your data. Finally, we're going to be dealing with unstructured data. This is one of the coolest things coming out of analytics world right now. If you go to a site called Kaggle, it's a big data science site. They just had a big competition for people to design a method for computers to detect heart valve degeneration by reading these MRIs. Now, it's just the computers doing the work. There's no doctors involved. And they're seeing this, and they're able to detect these changes. And this is the kind of stuff we're able to see. We're able to look at data we were never able to look at before and make sense of it. Your unstructured data is your videos, your pictures, this free text. These are the free notes that your doctor is writing in.
It's not stuff that neatly fits in a column of an Excel spreadsheet, like in a date, hire date and salary. You know what's in those columns. Free text could be anything. So it's learning how to dig through this data. The benefits are we beat inferential statistics using big data. We remove uncertainty. The easiest explanation I give for that is an election. Think of you're running for mayor in a town with 50,000 registered voters. If I go and I poll 4,000 of these voters, I can use basic inferential statistics and say, candidate A has 60% of winning with a margin of error. If I poll all 50,000 of these voters, I'm not guessing who's winning, I know. It's the law of large numbers and statistics, and that's what these large, big data sets are allowing us to start doing, which really enhances our predictive modeling skills. And one of the cool things when you start doing predictive modeling and looking at this is you're seeing things that are very counterintuitive to what we thought. A good example is Netflix just released a statement saying that age and gender are garbage when it comes to predicting taste in movies. Now, I don't know about the rest of you, but I think Justin Bieber's new movie would go to 12-year-old girls, but apparently that doesn't help you in predicting anything. So they have found other predictors are better when they're judging what kind of movies they want you to put up there for you to see. And the other thing it allows you is fast, agile decision support. Most of us live in a reporting structure where maybe once a week you run a report, maybe you run a monthly, a quarterly. You look at your budget overall, maybe once a year on a massive report. When they start feeding these massive data sources through, you can make these decisions a lot quicker. These reports are constantly learning, constantly churning out. So my favorite statement about big data is always this: the big data is like teenage sex. Everyone talks about it, nobody really knows how to do it. Everyone thinks everyone else is doing it, everyone claims they're doing it. Stan, I'm not going to try to mispronounce his name. He's an economist. He's kind of one of the guys responsible for naming it big data, so we can all blame him for the buzzword. Okay, so why even bother on the clinical engineering side? Most of your departments, you're sitting on a wealth of untapped data that a lot of you guys don't know you're using. Actionable data can be found in your computerized maintenance management system. Your data can be used as part of performance improvement initiatives. Think Lean, think Six Sigma. I'm going to focus here on realistic analytics. Easy to action, affordable. I'm using tools like Excel, Crystal Reports, Excel Miner, Tableau. Tools a lot of you may already have. Otherwise, these can all be purchased for under a couple thousand. I think Tableau's is $1,000 for a single license on it, as opposed to getting a hold of SAS, which is 25 grand just to start. And these are also a lot more user-friendly. SAS is great, but unless you want to become a programmer, I'd stay away from it. Okay, so questions many healthcare organizations want to answer to. Here's the kind of questions you're going to look for in your data. Is my spend increasing in a specific modality OEM product? You know, looking across there. Am I suddenly buying more parts? Why is this happening? Benchmarking. How do I compare other healthcare organizations? That's the great reason we got Erin and me. I'm going to talk about, my examples are all going to be data found from my single healthcare system. And she's going to show how we can look at multiple healthcare systems, compare one to mine, and that's where you can start to see patterns you may not see in other places. Mm-hmm. You can see things like she's going to mention a fraud detection thing you could spot that you would not spot looking at your own data. Okay? What am I spending by tech, by site? You know, what am I spending on by tech, by purchaser, things of that nature?
Yep. Some of the other things our customers have asked us for, and two, we've just, gleaned from playing around with the data, is, are the techs overusing overnight shipping? So big expense, things like PM kits, batteries, shouldn't have to be shipped overnight. So monitoring those, reporting on them, looking at, who's overusing a feature like that. Another would be, how are the vendors that I'm purchasing from performing? Do their parts go on back order frequently? Do they deliver on time? Is the quality high? Another one would be deliverability rate. So I touched on that one, but how many vendors am I purchasing from? So out of all of the people that I'm purchasing from, how many am I purchasing from? How many terms am I managing? And then the quality rates is something we really, really focus on. And want to make sure that there's visibility to that. It's important. You want to make sure that as you're buying parts over the next several years from that supplier, that the quality is high, that you're not seeing a lot of DOA rates. So the other one would be, how do they compare to their peers? So I'll give you guys a couple case studies where we had some customers that wanted to look at, and we personally wanted to look at as well, how does this vendor compare to the OEM? So you have these secondary manufacturers out there that are manufacturing infusion pump parts and pulse oximetry cables and things of that nature. Well, how do they compare to the OEM? I want to make sure, even though I'm saving money, I'm not risking any quality on the other side. So we'll go through some case studies on that as well.
Okay. All right, so the steps to analyzing your data. The first thing you got to do is pose a question, obviously. What are you looking for? Are you looking, how much am I spending this year? Am I overspending on a product? Things of that nature. Gather your data and prepare and clean. Now, see, these two steps right here, I think, are the stopping point for most people. Cleaning data for any data professional is 60 to 70% of the time you're going to spend on a project. And if you aren't well versed in some tools and techniques for cleaning data, it's going to become so frustrating you're just not going to want to deal with it, merging data sets together. Real quick, at the first page, I know it's really hard to see. I have a website here that's analyticsforall.org. I started it as a grad school project. It's like half complete, but when I knew I was coming here, I put in some Excel stuff on how to use some Excel tools to merge data sets, merge multiple data sets together, how to clean your data, how to do a lot of tricks within Excel that maybe you guys haven't known that will speed up the data collection process. Because like in a later example, I took my data from my CMS and I called IT and I got the data on my PACS, how many cases are being used. I merged them together using just Excel tools of that nature. And you can do it a lot faster than sitting there and trying to type each thing individually. Then you want to choose your tools and your technique. Tools out there, we're going to focus on like visualization, Tableau, Excel, things of that nature. And how you're going to do it. You want to visualize, you want to do a statistical model. Then you're going to finally summarize and visualize your data. There's two types of visualization. There's visualization I use where I'm I'm exploring the data. Then there's visualization you're going to use on your report you're going to pass off to the managers, and then analyze and interpret the results. And a lot of this is actually done on the management side. You're going to give this to the end user. Here's the data we found. They get to analyze and interpret the results. And this is a great example. I call this is the perfect world example. I'm going to go 3 examples. I'm going to do a clinical, an operations, and a business example. Alarm fatigue. It's on top of everybody's list. It's a real pain. So we try to bring it down. So I started collecting the alarm data out of our Philips system back in August. It's another example of unstructured data because they do not cleanly tell you what's coming out. I had to write a big program to break the data apart. But I gave it to one of the managers, and she ran with this like you wouldn't believe. And she beat her people down. She changed policies, changed procedures, she changed the alarm limits. And by getting these reports on a mix of weekly and monthly reports, she's managed, as of April 2nd, to reduce nuisance alarms by 54%. We had, in this one department alone, this is our tele department, we had over 35,000 weekly nuisance alarms. These are the yellow alarms. These are your red, these are high, these are your NOP alarms, like battery dead, things of that nature. But you see the nuisance alarm drop. One of the cool things we just found, this is like fresh off the press, was as she already got rid of the big ones, obviously she cherry-picked the big problems, got rid of them. Now she's down here looking, and she noticed the systole was weird and high. What? A systole? Okay. And she goes, why is the systole high? So she found out that the problem is when the nurses were coming to discharge a patient, they're taking your telepack, pulling it off, throwing it on the table, working with the patient, talking. The whole time they're doing it, that thing's throwing alarms, throwing alarms. So she's now instructed her staff to take the battery out first. And I'm thinking the next run of data I do, we're going to see a big drop in these systole alarms. So, and again, and I say this is a perfect example because I've also given this data to some other managers in other departments, and theirs looks flat. They have not taken advantage of it and used it. So it's all about having, you can build all the greatest data in the world. If you can't get somebody who will make a decision with it, it doesn't do much. So you do need to partner with good leaders that can help you make decisions there. Okay. This is operational. This is a data exploration game. I mean, if you guys got any kids who are ADD and like math, there's hope for them in data because it's the perfect ADD toy. You get to bounce around. What I did very simply was I just pulled 9 months worth of work order data out of my system, dumped it into an Excel spreadsheet, and started doing pivot tables. And I started asking questions. One thing I said, well, who's got the most work orders by class? Well, it all came up in fusion pumps. I'm sorry, this is hard to see. But it's not a surprise, right? In fusion pumps, it's probably the most repairs we're going to have. Is there anything we can do about it, though? I mean, because everybody accepts the fact, yeah, it's fusion pumps, but really, look at data. Maybe there's something we can do to make it a little bit better. Well, I looked at one hospital here. 20 pumps out of 1,412 made up 14.4 days of work in a 9-month period. That's 1.4% of my pumps made up 12.7% of all repairs on these pumps. So I got some lemons here. So my suggestion is either throw these in the wood chipper or reach out to the manufacturer and say, hey, you got to swap these out. I mean, I got 20 pumps eating up this much time in 9 months. So that right there will drop the repair times, looking at things like this. And then I continued on. I said, all right, well, I checked out by class. Let's check out by the actual equipment. So I went through and I did a work order count by actual individual pieces of equipment. Now, I happen to know these 2 computers, the server and the central station. Those work orders were due to me. Those were because I was doing, we were doing testing every week. So I was making a work order each week for this testing for configuration. So those weren't really repair. The next one is ultrasonic washer. Well, now you do a little investigation here. So what I did is I found out that I walked past the guy who does our sterilizers, and he had this tag number sitting by his desk, written on a piece of paper. So what he was doing when he was going up to fix stuff, instead of like getting the tag information correctly, he was just coming back and making work orders with that tag number saying he had to fix this, just to get his work order numbers up. He wasn't doing. And this one was really fun. Dental chairs. Now this is 9 months, maybe even 7 months worth of data. In my 16 years of biomed, I can count on a hand how many dental chairs I fixed. I'm like, what's going on? Well, I went and looked at who was doing it. It was one of our younger guys. So I walked up to the dental clinic, and I saw the new dental staff. I think he's in love. That's why he's fixing it. That's why he's up there each week. So through data, we've discovered puppy love here. It's good to be 24 in a hospital, But again, looking at this, though, At half an hour repair, you're looking at 69.5 hours on this. Over 8.5 days spent on these three. If this was actual repair time, you'd have to look at this. 8.5 days spent on these three machines alone. And this is the kind of stuff you want to look at. I mean, and some other stuff, just I don't want to kill too much time, just playing around with this data too. I was able to find length of time from the repair till somebody looked at it. Departments people don't want to go to. Equipment people don't want to touch. You know? So the last one I'm going to go over is a business. This is a budgeting forecast, and I'm sorry this is completely unseeable here. Hopefully we can push the slide out of easier. What this was, this is a 5-year projected forecast model I built for replacing our DI equipment. We were asked to make a 5-year forecast. So I went out and I reached out to some vendors, and I got end-of-life support information. I reached out to my PACS solution, and I said, can you send me how many cases each study's doing? So thinking to myself, I have 2 CTs, same age, everything, all things being equal. One's doing 20 cases a day, one's doing 2 a week in a clinic. Which one am I going to replace if I had the money for it, the higher mileage? So I built a scoring system built on the amount of, this, I know it's hard to see, this is the repair. So in the red, this is getting higher repairs than average on normal. This is end-of-life support score, and I scored it on a scale of 1 to 9 with a weighted score on it. And then I also did a technology score, and where I reached out and I talked to some of the departments, is the next version, is it got something really cool that you can't do now, or is the next version just the shiny new version? Because if you can't do a study now and patients aren't coming to you because your version of your MRI doesn't have this software, then we need to look at replacing that. And also, of a lot of imaging now, the problem is with the new reimbursements, if you're not digital, you're not getting full reimbursement. So those are some of the, and when you're talking to your finance guys, they want to hear that. I'm losing money, so we need to replace it. So I combed all these scores together. But what I did is, I took a bunch of desperate, simple, separate data sets, munged them all together to create this. And that's where, using the data cleaning, data merging techniques came in. And I just developed a quick scoring so you can see what year is weighted along there and how much it's going to cost. Okay.
Perfect. So one of the areas that, as Ben was mentioning, a customer had come to us was to ask for, they were making a capital equipment decision on infusion pumps, and they wanted to better understand how OEMs compared to one another. So they looked at 2 OEMs and asked us the question on, one, what are some of the common failure parts? So for these models, these are the models that I'm interested in purchasing. What are some of the common failure parts? Number 2, they looked at, outside of obviously just the price of the equipment and all of the bells and whistles that come along with it, but they also wanted to understand part deliverability. So how do they perform? What are their back order rates? Do they ship on time? And one OEM floated up much higher than the other. So in that year, they had 3 parts that on average had a lead time of 14 days. So, and there were 2 of the most common failure parts of the top 5. 2 of them fell into that bucket. So that was something that helped them make that decision. They wanted to make sure that as they're supporting the equipment, obviously they're able to support it in a timely manner. The other thing that we'll look at is, I mentioned even by model, some of the common failure parts that you would see. And then 2, parts availability. So is it just the OEM that I can go get these parts from? Can I get them from other suppliers? 1. And then 2, what are some of the repair capabilities? So with these 2 OEMs, one of the things that we were able to share is the lead times that we've experienced. So we've experienced, when we send something in for repair to them, because one of the OEMs you're required to send the repairs into, we experienced a 14-day turnaround time. And that was the average over the past year that we had been sending repairs to that OEM. So all of those were factors that helped them, make a decision. And areas that, really we encourage all of our customers to leverage their vendors. We leverage our vendors for information too, and utilizing your peers too for, for information that they might have. So, on that note, we have, and it looks pretty, it looks fancy, but a lot of what we do is just basic things in Excel. So these are actually built out of Excel using a macro. We have a gentleman back at the home office, and you hit the nail right on the head. He came out of college and didn't necessarily know what he wanted to do. Was terrible at math. He has ADD, and he is a whiz in our building when it comes to, Excel and reporting and things of that nature. He designs a lot of this stuff for us. But it doesn't have to look like this. A lot of what we use is just plain, pretty vanilla. It's just, for us to gain some insights. But when you're looking at this, these are our vendor report cards. So this was another look that, that we did based on the previous slide. We were looking at the quality rates from a supplier. We were looking at the deliverability, as I was mentioning. 2, we were looking at on-time shipping, incorrect part order, so how frequently was the incorrect part shipped. And the other thing that we looked at, this is another case study using the same 2 reports, were what I mentioned at the beginning of the presentation. So we had a customer that came to us, this was a service organization customer, and they said, I've always historically bought OEM original parts. That's all I've bought. I've never really dipped my toe in the water for secondary. So I understand that there's cost savings available there, but I want to see what my risk is. Increased risk, or increased savings, what's the risk associated with it? So we looked at a couple categories. One was pulse oximetry cables, and the other was batteries. Looking at the quality rates between a new non-OEM and a new OEM original. And then we did the same thing, compared to refurbished, et cetera. And the customer really got to see, okay, with a little increase, in risk, I can save X. But really what they saw was that, the difference between the OEM original in these cases and the OEM replacement was the quality rate was within 0.2% of each other. So that's another area that we've helped, our customers kind of glean some information on questions that they wanted to answer. So this, just dovetails into the prior slide, but this was another customer that we had, wanted to look at various conditions, but they wanted to look at them, in a more granular fashion. So they said, I want to know on biomed and imaging, and then within each modality, what are the quality return rates for these conditions, 1. Number 2, the other thing that they wanted to understand is what were their return rates. So as a customer, how many returns did they have where it was the technician's fault? So something that we document is when a return takes place, if when we receive that return, what we'll do is we'll ask the return reason, of course. The technician may say, oh, I misdiagnosed the system and I need X part instead of Y part. So we document each one of those, but the customer wanted to understand, is there a specific modality, is there a specific person that is misdiagnosing systems frequently? Maybe we need some retraining, maybe there's another issue. But those were some of the things that they were trying to understand from the data that we put together here. So this one is based on spending benchmark. So Ben mentioned at the beginning, we've had some organizations say, how do I spend in a specific modality or manufacturer compared to a healthcare organization of my size? So really looking at what they're spending. So we'll look at a few different things. 1, bed size, so how many staffed beds. Number 2, how many clinical engineers do you have on staff? And then there's some other factors, if the customer shares information with us that we'll, use to find an exact match, of healthcare organization. So what we do is we look at overall spend. So just in general, what do you spend compared to the other healthcare organization? Number 3, we'll look at, biomed, imaging, and glassware. And then the last segment would be deeper repair. So small shippable devices, your Philips MMS modules, infusion pumps, suction regulators, things of that nature. So we create some benchmarks, and customers found it was interesting just to look and compare to their peers. So that's one element that we can use as a comparison. So user level purchasing behavior, this is something that, customer was looking at their data and did their best cleaning it up and trying to better understand what was happening at the tech level. So we started playing around with the information, and we just used Excel. On that note, we didn't purchase an SAS system until 2 years ago. So prior to that, we were always using Excel, and Excel is a wonderful tool. Just doing some research on some of the things that it can do, it's amazing. I've learned a lot, and I've learned it not through college courses, but actually doing it, actually playing around with the data. But with that, just using Excel, we started looking at the technician data, and what we were looking at was 1, some of the return rates that I was mentioning previously, but 2, the overnight shipping was their biggest concern. our overnight shipping has increased significantly. What's going on? So what we did is we created a report for them, and it showed a couple things. We looked, by site, by technician, how frequently are parts shipping overnight? What percentage of the time are they shipping overnight? And then drilling down to the technician level. The other thing that we looked at was anything that was purchased that was a PM kit or a battery, typically things that don't have to ship overnight, there's usually some planning involved there, is what percentage of those products were shipping overnight? And then again, drilling down to the technician level. But it really helped them mitigate cost on overnight shipping just by understanding. They specifically had 2 techs that were purchasing frequently. It was mainly PM kits for their Puritan Bennett ventilators. They were shipping them overnight, so they weren't planning in advance. And then they were shipping bulk batteries for their infusion pumps overnight as well. So expensive. But being able to identify those things are, other areas that they were able to identify some areas to cut costs. Those are made up to protect the innocent. Actually, not the innocent. But so yeah, we looked at all of those areas. The other thing that we'll look at too is savings by technician as well. So you have multiple options to purchase from. When you go to look for a part, OEM original, OEM replacement, refurbished, etc. You have some people that will always want to purchase OEM original. Well, you might be missing out on some savings. So we'll identify there too where there might have been some additional savings opportunities.
One thing with her getting a benchmarking of purchasing and buying is things like fraud detection.
Oh, I
you can
forgot
pick up.
that. Thank you.
Now, if I've got a guy who's running his own little CT repair business on the side, if he's smart, he'll buy parts across 10 different CTs evenly. So when I look at the spend, it doesn't seem abnormal. But if I can get a benchmark from her and compare, this model of CT, and she's telling me in the past 5 years, people are normally spending this much a year, and I've hit and above, there's a reason. That's going to jump out. You can't get that looking at your own data alone. You have to reach out to other people and look, and that's where you can get these comparisons. You can find stuff like that otherwise a savvy guy could probably hide from you.
No, and that's a good point. That was one area where they saw a pop in one specific modality. So we drilled down to the user level, and it turns out that they had 2 techs that were buying parts with hospital POs, taking them home and utilizing them for their own business. So things like that, scary, but it's
probably not too uncommon, though.
Yeah, it's right. But drilling down, to that level helps identify those things.
All right, some of the key takeaways. The data's at your fingertips, and you can help with all aspects of HTM. I know a lot of us are thinking operations and business, but reach out, be a clinical resource. If you can provide data, you have the raw data, you have the raw acquisition data. If you can pull it off, because like I said before, your IT department normally has an EMR, and their EMR says, we want these 5 parameters, they don't care about anything else. Well, there's other data that's not being collected that can be useful. Talk to your clinicians, provide this value to them so that you're not just the guy who comes and fixes something. Now you're somebody who's providing clinical value and business value. You're a resource they can go to. And that's always been one of the things that, where everybody complains, IT gets this and biomed's down here. Well, that's part of the problem is that IT jumped out in the beginning and became a resource. They hold the data there, they come to you, I provide the reports, the whole thing. We need to kind of on our end see what we can do, leverage the data we hold to try to get, level the playing field a little. Understand what you got in your system, reach out to vendors, get benchmark data, reach out to your part suppliers. If your part suppliers, whoever you're using, aren't willing to send you data, find a new part supplier. I mean, honestly. If you're not, hey, can I get what I bought from you in the past year? And they go, no, well then I'm going to go buy from somebody else, personally. If you're not going to give me the data, because this is, the new leveraging I think of when I talk to a vendor. Can I access the data? No. Well, then maybe I'll talk to somebody who will let me access the data because it's my data. I don't care what vendor, I don't care if you're Philips, Tracemaster. Those EKGs are coming from my patients, so it's my data. If I can't access it, then I'll go to GE. Maybe they'll let me access it. And flawed data is still useful. This is probably the most important thing I want to point out. A lot of people don't use stuff because they oh, my guys aren't filling out all the information. Yes, there is no such thing as a perfect database. Everybody's data I can go to, I can promise I can find just problems and problems with it. That's okay. There's still, if you start digging around, there's still a whole lot of other information you can pull from your system. And once you start producing these things, you find these pumps, tell your guys, hey, get rid of these 20 pumps because they're a pain in your... They're going to start to see the value in what you can find in the data, and you can use that to encourage them, hey, maybe you guys can start filling your parts orders in there. And finally, you can utilize free or low-cost applications. Almost everybody has Excel, Tableau. There's actually a free Tableau public out there if you want to try to get a hold of it. I mean, when I talk about once you've tried it, you'd be like, why haven't I never used this for just quickly visualizing things? And leverage your suppliers, like I mentioned before, and talk to your peers, see what they're doing with it.
Yeah, we did, Ben did a presentation at our customer summit last year, but just asking, just the presentation that Ben gave, it really helped, people in the audience, a lot of other, folks that Ben hadn't interacted with before, but gained a connection, and you start talking about, well, here's what I've been doing with my data, and understanding how others are using it, might help gain some insights on things that you can do. And the other thing that I'll mention is, sometimes you know what question you're trying to answer. It might be a little unclear, going into it. I see an increase in, spend here. I'm going to start digging in. But it's really just starting to play with the information. That's how I usually start. I throw it in Excel. I do some quick pivot tables. And when you start playing around and putting things in different places, things pop out. And that's really where I've learned a lot of the skill sets that I have in Excel, which are probably minimal compared to somebody like Ben. But it's really using it. It's using it in those real case scenarios, playing around with it, making mistakes, that you really start to get some answers and start to improve those skills.
Is there any chance I can get this computer online? Look at a website real quick? No? Okay. All right. One thing I wanted to show, I forgot, I should have put it up there. One thing great with Tableau I used was taking your PM schedules. And I've got it actually up on my website. If you look under visualizations, I got a picture of it. And I visualized it in a bar chart. And each bar inside the bar chart had, each section was a department. And you looked at the PM schedules were like this across, and you're like, well, how can I clean this up? Well, you saw right there. I can grab this block and put it there, grab that. Instead of staring at these sheets and sheets, how quickly, and once you build that, you connect it to your database, you don't have to rebuild it again. You can just look every month and see when stuff starts to shift and move. So the visualizations are one of the best things really to look at data as a whole. Instead of staring at columns and columns, learn to use graphs, learn to use charts.
Any questions? Quite group. The website?
The website? Oh, yeah, it's...
Let's go back.
Sorry, the screen is... It's analytics number 4 all.org. And a lot...
This presentation is going to be online
later
on, so you can find all this information.
And I started this actually as I was doing a Python thing in grad school, but I threw some stuff together because I know it's coming here, and I added. So this is an open analytics site. I'm not talking about just biomed for anybody to use, just how to learn certain tools. So I've got some information on some basic Tableau, some Excel, things of that in there, that kind of get you started. Yeah.
So Ben, you mentioned that you were able to get someone from your IT department to pull streams of data from your PACS system and I guess your CMS, right, for that equipment replacement planning?
Yeah,
I've struggled. We get the scope utilization data comes out, is collected in GMAD, and I can go into GMAD and I can see that it's by serial number what scopes they're using. But God, I'd love to have that come out and be merged somehow with with our CMS. And sort of what kind of leverage do you have to pull to get that happening with your IT folks? I mean,
I guess some of it's the relationship you can build with them.
Is it a big task to
Some
grab those
certain
data
people, not really. No, what they're dumping is you're asking them something specific. I just want by serial number the number I wanted by. For me, it was the AE title, the number of cases you've done. So he just spit that out and sent it to me in a CSV file. You know, and I guess
okay,
it's
so it's not a
no, it's
a linked.
no, not a linked. I do most of the work in Excel. Now and I know it kind of sounds. Once you've built the model, it's not so hard to do anymore. I don't like, especially a lot of the cleaning and stuff. I don't like to do it on my original data source. I personally suggest, even if your data is flawed, leave the flawed data as it is. Just, you know, if it's wrong, change it. But if they're missing stuff, it's missing. You can fix it in the cleaning process. Export everything into Excel. Do your work there. Because honestly, when you're cleaning data, normally you're cleaning with a purpose. I know for a fact this is what I'm looking for, so I'm going to clean my data so I can make this work as easily as possible. My problem I've seen, like in CMSs, is that you got an administrator up there who's like, well, I know I have to do this report every month, so I'm going to change the way things are named in the system so I can make this report easier for me. And then you go to find something, you can't find nothing because she's the only person who knows how that report was made. Now, she's changed things. That's why I hate changing the raw data. Export everything into Excel, and you can merge them together in that point. And you can build, there's tools like SSIS, which really aren't that hard to learn. They're very visual. And if you want, you get the streams. And if you could get somebody maybe monthly to send you the streams, they export, you push a button, they merge together once you've built the merge, you know. And those are, if you have any SQL Server license out there, it's free. You know, it comes with the SQL Server license. And there's other tools out there, obviously, that you can try the merging. You know, once you learn to put stuff together like that, take disparate sources and put them together, it's not that bad, and you've built it. You know, the biggest note I can tell anybody, though, when you do it, write down everything you've done. Because next time you do it, it's going to be 6 months from now. You'll be like, oh, and you're starting all over again. I know I had to rename something, you know.
And there's also some good websites. I know that we've used it at PartsSource a lot. Is it Lynda?
Lynda's great.
Yeah, Lynda. It's great tips and tricks in Excel. So if you don't know how to do something, I use it all the time. You Google, how do you do XYZ in Excel? Lynda comes up frequently. I have learned probably half of the skills that I have today in Excel just from that website.
Another great one we're using is called Plural Site, which, now we only bought 5 licenses, so you may be able to get better with more than 5 licenses. About $500 a person, unlimited for the year. And Plural Site has everything from Excel to how to develop an Oracle database. It is every IT skill you can possibly think that you need to master. They have networking, and they have all the, you could watch the videos and go take a certification test watching these videos. And again, if it's for $500 a user, what we're paying for 5 users, unlimited. If I sat and want to watch videos 24 hours a day, they don't care. And you can rewatch them, and they have exercise files you get to download. Because that's very important, is to be able to download like exercise files. Plus, they offer testing at the end. So you can see if you guys are actually watching it and absorbing it, because you have to take a test when you're done, and you get a certification that you passed the test for this module you watched. And I can't tell you how many times where I've just had to, oh yeah, I've got to set up a terminal services on my server. God, I did that 6 months ago. How do I do it? Logged onto Plural Site, found it, watched the section of the video I wanted to see, and I was done. Versus digging around everywhere and trying to remember. Plural, yeah, Plural Site. I mean, there's others out there. That one's from experience. We're using it, and I do really like it. And I've gotten great, and they're continuing to add a lot of data to it, to a lot of courses. If you want it for home use, cheaper things, there's a place called Udemy, where you can normally pick up a lesson for anywhere from 10 to 20 bucks. But once you own it for the rest of your life, which is nice. This Plural Site's a subscription, and it's through work. If you leave, obviously you won't go to a different place, you won't have that. But for personal use, Udemy, I can't talk highly enough. That's how I learned Tableau and crystal reporting. Was Udemy, U-D-E-M-Y. And another cool software out there, if you guys are looking at, you know, visualization dashboarding, is to look at it. It's up and coming. It's called Click with a K, Q-L-I-K. you can build these dynamic dashboards. It really has taken what Crystal did and blew it out the water. I mean, they're going to sink SAP unless they pick up. They're going to be in trouble.
Yeah, if there's no other questions.
Yes.
Thank you all for attending. We appreciate it.
Yep.
Have a great rest of the show.